Hey everyone, and welcome to today's deep dive. We're going to be diving headfirst into self-driving cars.
Oh, cool.
Specifically, how they can be taught to navigate tricky situations. Like we humans do.
Okay.
You know, like when a pedestrian is about to cross the street, even if they haven't made eye contact with you yet.
Right.
It's all about predicting the future, and that's where VisionTrap comes in.
Yeah, it's really fascinating how us as humans, we kind of just do this subconsciously, right? Our brains just process a ton of visual cues, and we just kind of know.
Exactly. But traditional self-driving systems, they haven't quite mastered that whole sixth sense yet.
Yeah.
They rely mostly on sensors like LiDAR and radar, which again are great for detecting objects, but they don't always capture the full context of what's happening.
Yeah, it's like trying to understand a conversation, but you only catch a few words here and there.
Okay.
You might get the general idea, but you're missing a lot of the nuances.
Okay, I like that analogy.
Yeah.
So how does VisionTrap change the game?
So imagine giving a self-driving car the ability to not just see its surroundings, but also create little captions describing what it's seeing.
Right.
Like pedestrian waiting to cross or car slowing down at a yellow light. That's essentially what VisionTrap does.
Interesting.
It analyzes camera images and translates them into textual descriptions, which adds a whole new layer of understanding.
So it's like giving the car a mini interpreter to help it make sense of the world.
Exactly. And those textual descriptions, they're key.
Okay.
They provide crucial context that sensors alone might miss, especially in those tricky situations where traditional methods often fall short.
This is already blowing my mind, and we're just getting started.
Yeah.
So let's break down how this actually works. What are the nuts and bolts of VisionTrap?
Well, think of it as a three-step process.
Okay.
First, you have image pre-processing.
Okay.
This step is all about cleaning up the raw images from the car's camera.
Gotcha.
Kind of like enhancing a photo before you share it online.
Making sure those images are Instagram worthy.
In all seriousness, this step ensures that the images are optimized for analysis.
Makes sense. What happens next?
Next comes the really cool part.
Yeah.
The Vision Language Model, or VLM.
Go.
This is where the magic happens. This model acts like a super observer, taking those pre-processed images and turning them into those descriptive sentences we talked about.
So it's like teaching the car to not just see, but to also understand and describe what it's seeing.
Precisely. And that deeper understanding is what allows VisionTrap to make much more informed predictions about what's going to happen next.
Okay, I'm on the edge of my seat here. What's the final piece of the puzzle?
The final step is where it all comes together, the trajectory prediction model.
Okay.
This model takes both the visual information from the images A and D, those rich textual descriptions from the VLM, and uses them to calculate the likely paths of everything in the scene.
Wow.
Cars, pedestrians, cyclists, everything.
Wow. So it's like VisionTrap is giving self-driving cars a glimpse into the future.
In a way, yes. By combining visual and language processing, VisionTrap allows these cars to anticipate potential hazards and make more informed driving decisions just like we do.
This is incredible. So we've got these textual descriptions, but why is this so groundbreaking? How does adding language into the mix actually improve prediction accuracy?
It's all about context.
Okay.
Think about those classic optical illusions where you see one thing, but then someone's like, look again, and suddenly it's something completely different.
Right.
Our brains use context to fill in the gaps and make sense of what we're seeing.
Yeah.
And VisionTrap does something similar for self-driving cars.
So it's like VisionTrap is giving these cars a dose of common sense.
Exactly.
Like when you can just tell that a pedestrian is about to step off the curb.
Right.
Even if they haven't looked up from their phone yet.
Traditional methods relying solely on sensor data might only register that there's a pedestrian standing near the road.
Okay.
But VisionTrap sees the pedestrian, but also interprets their posture, maybe the way they're looking down at their phone.
Yeah. And adds the description distracted, providing much more valuable information for predicting their next move.
And this is especially helpful in those chaotic real-world situations that traditional systems struggle with, right?
Absolutely. Intersections are a perfect example.
Okay.
Imagine an autonomous vehicle approaching a busy intersection. Cars coming and going, pedestrians crossing, cyclists weaving through traffic.
Right.
Traditional systems often have a hard time predicting what will happen next in such a dynamic environment.
Yeah.
They might get overwhelmed by all the moving objects and make an overly cautious or even dangerous decision.
It's like they're trying to solve a jigsaw puzzle with only half the pieces.
Precisely. But VisionTrap, with its textual understanding of the scene, can make much more nuanced and accurate predictions.
Okay.
It doesn't just see objects moving. It recognizes a pedestrian crossing the street, a cyclist signaling a turn, a car speeding through a yellow light.
Right.
That deeper understanding is crucial for navigating complex scenarios safely. This is all starting to make so much sense. But earlier you mentioned that VisionTrap also helps overcome a major limitation of traditional methods. Occlusions.
Right.
What exactly are occlusions and how does VisionTrap handle them?
Good question. Occlusions are simply things that block the view of sensors.
Okay.
A parked truck, a building, even a crowd of people.
Right.
Anything that obscures the line of sight can create an occlusion.
So it's like when you're driving and a big truck is in front of you and you can't see what's on the other side?
Exactly. Traditional sensor-based systems might only see the truck, but VisionTrap can often see what's behind it, thanks to its ability to create those textual descriptions based on the surrounding context.
Okay, so walk me through how this works in practice.
Okay.
How can VisionTrap possibly see something that's hidden from its cameras?
Let's say a pedestrian is about to cross the street behind a parked van.
Right.
Traditional systems might not detect the pedestrian until it's too late because the van is blocking their view. But VisionTrap, using its textual understanding of the environment, might generate descriptions like crosswalk ahead or pedestrian likely to cross.
Okay.
It then uses that information, combined with what it can see of the surroundings, to infer that there's a high probability of a pedestrian emerging from behind the van.
Wow, so it's like VisionTrap has developed a kind of intuition or sixth sense about what's likely to happen, even when it can't see everything directly.
That's a great way to put it. This ability to handle occlusions is a major step forward in making self-driving systems more robust and reliable in those unpredictable, real-world situations.
This all sounds amazing in theory, but how does VisionTrap actually perform when put to the test?
Well, the researchers behind VisionTrap were curious about that too.
Okay.
So they put it through its paces using a massive data set called nuScenes, which contains real-world driving data captured from various locations and driving scenarios.
So they essentially created a virtual proving ground to see how VisionTrap would handle all sorts of challenging situations.
You got it. They threw everything they could at it, from busy city streets to winding country roads.
Wow.
And the results were pretty impressive.
Yeah.
VisionTrap consistently outperformed traditional methods when it came to accurately predicting trajectories.
Interesting.
Particularly in those complex scenarios where other systems struggled.
Do you have any specific examples of how VisionTrap shined in these tests?
One scenario that comes to mind involved a pedestrian crossing the street between two parked cars.
Okay.
Now, because of the cars, the pedestrian was only visible to the system for a brief moment,
Right.
making it a real challenge for trajectory prediction.
Yeah.
Traditional methods, relying solely on sensor data, often mistook the pedestrian for a stationary object once they were out of sight.
Yeah.
Which could lead to a dangerous situation if the car didn't anticipate the pedestrian stepping out from between the cars.
That makes sense. They were working with incomplete information.
Exactly. But VisionTrap, with its textual understanding of the scene, knew that pedestrians often cross between parked cars, and was able to maintain awareness that a pedestrian was present, even when they were briefly hidden from view.
It's like VisionTrap said, hold on, I know what's going on here.
Precisely. And because of that deeper understanding, it was able to make a much more accurate prediction of the pedestrian's path, potentially preventing an accident.
Okay, so VisionTrap is clearly a game changer for making self-driving cars safer and more reliable.
Definitely.
But what does the future hold for this technology? Where do we go from here?
Well, that's the question on everyone's mind, right? Like, where do we go from here? VisionTrap has already shown incredible potential.
Right.
But like any groundbreaking technology, there's always room for improvement and expansion.
So what's next for VisionTrap? Like, what are the next big hurdles to overcome?
One of the most exciting avenues is exploring how to make VisionTrap even more integrated with other types of data that self-driving systems use.
So not just relying on cameras and text descriptions, but combining VisionTrap with things like LiDAR and radar to create a more complete picture.
Exactly. Imagine giving VisionTrap access to the precise distance and velocity measurements from those sensors.
Oh.
In addition to its textual understanding of the environment.
Yeah.
It would be like having a whole team of experts working together.
Right.
Each contributing their own unique perspective.
It sounds like the future of self-driving is all about collaboration.
Yes.
Both between different technologies and between humans and machines.
Absolutely. Another exciting area of exploration is incorporating even more diverse types of data,
Okay.
what we call multimodal inputs.
Oh.
Right now, VisionTrap focuses on visual and textual information.
Right.
But what if we could add audio into the mix?
Interesting. How would that work?
Think about it. The sound of a car horn honking,
Okay.
tires screeching, a siren in the distance. These are all crucial cues that human drivers use to anticipate potential dangers.
Right.
Imagine giving self-driving cars that same level of awareness.
It's true. We rely on our ears so much when we're driving,
Yeah.
even if we don't always consciously realize it.
Exactly. And then there's GPS data,
Oh, yeah.
real-time traffic updates, even information shared between vehicles on the road. The
Wow.
possibilities are pretty much endless.
It sounds like we're talking about creating a truly intelligent driving system,
Yeah.
one that can process and understand the world in a much richer and more nuanced way than anything we have today.
That's the ultimate goal. And while there are still challenges to overcome, like
Right.
making these complex algorithms run faster so they can work in real-time driving situations,
Right.
the progress we've seen with VisionTrap is incredibly encouraging.
It certainly is.
Yeah.
It seems like we're on the cusp of a major shift in how we think about autonomous driving.
Yeah.
We're moving beyond just reacting to what's right in front of us
Yeah.
and towards a deeper, more intuitive understanding of the entire driving environment.
Well said. And who knows, maybe someday soon we'll all be cruising down the road enjoying a cup of coffee, while our cars safely and intelligently navigate the world around us,
Yeah.
all thanks to a little help from AI that can see the future.
Well, I, for one, am excited to see where this technology takes us. And that brings us to the end of today's deep dive into the fascinating world of VisionTrap. We hope you've enjoyed this journey as much as we have.
It's been a pleasure exploring this groundbreaking technology with you.
And to our listeners, we'd love to hear your thoughts. If AI like VisionTrap can predict the future of cars on the road, what other applications do you think this technology could have in our increasingly automated world? Keep those imaginations running, and we'll catch you on the next deep dive.